Good afternoon, everyone. I am Tony Sturgis, and this is my final project for LN 440 Mechatronics course with Dr. Bolden. My final project consists of merging an IR sensor to act as a motion detector switch to deactivate a DC motor. To begin, I'll be going over as to what my statement of purpose is. The purpose of this lab exercise is to gainfully ensure the communication between a sensor and a DC motor through converging the two labs. This project is broken down into various segments, each of which contribute to the final product, which consists of deactivating a DC motor through a sensor which detects movement. The first portion of the lab consists of the DC motor lab construction, in addition to its ability that it functions with an off and on switch. The next task is to ensure the VI designed corresponds correctly with the physical portion of the lab. The final step would be implementing the IR rangefinder and ultimately replacing the on and off switch function with the sensor, while leaving the switch as a safety precaution or emergency cutoff switch. The end goal of this project is to design the fundamental requirements of a safety mechanism. For instance, if a robotic structure was performing its duty and came within limits of colliding with another object, this IR sensor would prevent such a scenario. This design could be manipulated to act as a proximity sensor to keep robotic arms within a specific range of motion. Now, I would like to go over my objectives for this lab assignment. The overall objective of this project is to gainfully understand how to manipulate multiple lab assignments to construct a larger, multi-functioning mechatronic design. The ultimate goal of this lab is to create and design a schematic that physically mirrors the VI created within LabVIEW. The task is to activate a DC motor through the detection of movement utilizing an IR rangefinder. This lab is useful as it is utilized within various applications such as proximity sensors, automatic trash can lids, or holiday gadgets that either sing or move when motion is detected. The objective is to actively employ the operation of a DC motor as a sensor detects movement, therefore powering down the DC motor once movement has reached a point within proximity of an unwanted distance between an object and the IR sensor. Now, some components used for this design include DC motor, the ZVP2110 transistor, along with a ZVN2110 transistor. Then we have the 1N4001 diode. Then we have the IRF510 power MOSFET, which will be used as a solid state switch. We have various jumper wires, the MyRio itself, the MyRio breadboard, the selector switch, an IR rangefinder, a red LED, which all accumulates to approximately $630. Now I'll be going over the steps to constructing the physical design. Step 1 included the design of the DC motor and ensuring that its VI in LabVIEW would function as a virtual on and off switch. For this particular setup, I will be using port A and DIO 0 as for the communication link between the VI and the MyRio. Step 2 was to strategically implement the IR sensor so that once an obstruction was detected, the DC motor would cease all movement, which I have installed a red LED to display a present fault. I felt that it was important to leave the selector switch present on the breadboard to be utilized as a secondary emergency cutoff switch. Now, step 3, once the IR sensor was embodied into the design, the test phase of the lab presented itself, resulting in predicted action. The IR controlled DC motor theoretically would proceed as the VI's virtual switch is selected to on. This allows for the power to be distributed to the myReal breadboard and ensures that the connectivity is present. The next step would be to switch the selector on the breadboard to the on position, which would activate the DC motor to run continuously. Once the DC motor is activated and running, there are only 3 ways to shut off the motor. They are 1. Click on the virtual button in the VI. 2. Switch the breadboard selector switch to off. And lastly, 3. Obstruct the view of the IR sensor, and the cease of operation would result in the red LED to illuminate, indicating that there is a fault present. Once the IR no longer detects an obstruction, the LED powers off and the DC motor returns to its continuous work status. The overall objective of this project is to gainfully understand how to manipulate multiple lab assignments to construct a larger multi-functioning mechatronic design. Finally, here is a display of the product's operation. As we can see, the DC motor is running continuously, and if I were to obstruct the view of the IR sensor, we would see the red LED illuminate, and the DC motor would then power off. Now, this will remain off so long as the IR sensor is the view is continuously obstructed, but once the obstruction is removed, the DC motor will continue to run. And as I stated previously, I left the selector switch on, which would act as an emergency cutoff switch, therefore powering down the DC motor and acting as an emergency cutoff. As we can see, there's no more action once that emergency cutoff switch is activated. Well, there's the VI. Well, thank you very much for this opportunity, and see you next time.